Woodpeckers slam their face into trees. All day long, no big deal. That should scramble any normal brain. So how does its head survive that? Everyone has the same easy answer. Its skull must be a shock absorber. Basically a tiny built-in crash helmet, padded and totally headbutt proof. Let us test that big theory. Helmet on, tree dead ahead. Woodpecker blob rears back to strike. Then it slams its face forward. Cartoon stars circle its little head. So much for that fancy helmet. Tiny scientist storms in immediately, ripping that silly helmet clean off. That whole helmet idea is wrong. Real footage tells a different story. Super slow motion cameras caught something. The skull barely squishes at all. No spring and no cushion. The skull is actually a hammer. Stiff on purpose, not by accident. That sounds completely backwards to me. Shouldn't stiff and hard mean damage? Yet its tiny brain stays perfectly fine. Something else is protecting it instead. And it is stranger than any helmet. Woodpecker blob leans in real close. Let's crack open its skull secret. Let's talk pecking speed for a second. 20 hits happen every single second. That's faster than you can blink. Its beak flies at 7 meters per second. Picture a tiny feathery race car. Now let's talk about the crash force. Each peck can hit 1200 G. Astronauts black out around 5 G. Woodpeckers just shrug that off daily. Imagine a crash test dummy that small. That dummy would just fall apart. Woodpecker blob just grins and resets. Let's count how many pecks per day. Some woodpeckers peck 12,000 times daily. That's like headbutting a wall non-stop, all day long with zero breaks. Try that with your own forehead sometime. You would end up in the hospital. Woodpecker blob just keeps hammering away. So how is that even possible? For years, scientists had one big guess. A built-in helmet inside its skull. A soft, spongy cushion around the brain. Like bubble wrap for a tiny brain. That idea sounded pretty reasonable, honestly. Textbooks repeated it for decades straight. Even we believed it a minute ago. But scientists kept poking at that idea. Something about it never quite fit. A new study cracked the whole mystery. In 2022, researchers finally got answers. They filmed real woodpeckers pecking up close, with cameras fast enough to freeze time. What they saw changed everything instantly. The beak and skull stop together. The brain stops at that exact moment too. No cushion and no delay at all. Everything moves as one solid piece. That means the skull isn't a shock absorber. It's actually built to be stiff. Basically, its whole head is a hammer. A soft skull would waste all that energy. Cushioning would actually ruin the peck. A stiff hammer drills wood way better. So the whole helmet theory was wrong. Time to throw that old idea out. Straight into the trash it goes. Woodpecker blob is officially a walking hammer. Not a bird wearing safety gear. A tool disguised as a bird. Let's talk about how fast this happens. Each impact lasts less than 1 millisecond. Way quicker than a camera flash. Faster than you can say ouch. Some measurements clock over 1,500 grams. That number would flatten most animals instantly. Woodpecker blob barely even notices anymore. Its whole body is built for this. This bird is basically a living tool. And that mystery is finally solved. Time to talk brain safety math. Woodpecker brains are seriously tiny, about 700 times smaller than yours. Small brain sounds risky at first, but size actually works in its favor. Smaller brains handle sudden stops better. Think crash test dummy in a tiny suit. Scientists measure this with scaling math. Bigger brains bruise easier from impact. Tiny brains barely notice the same hit. It is basic physics, not magic. Smaller mass means smaller brain strain. So how big is the safety margin? Woodpeckers hit hard every single peck. That speed is nowhere near dangerous territory. Researchers estimate a big safety cushion. Concussion risk needs way more force, roughly double the speed to get there. That is a lot of extra buffer. Humans would black out way sooner. Tiny brains barely feel the wobble. It is basically riding a tiny roller coaster. Meanwhile, our brains would need airbags. Scale really changes the whole equation. This is why ants survive huge falls. Same rule, different tiny daredevil. So the tiny brain is not fragile. It is built for exactly this job. Nature basically pre-installed the safety math. But the skull is not the whole story. Meet the woodpecker's wildest body part. Its tongue is ridiculously long, about a third of its whole body. So where does all that tongue go? It literally wraps around the skull. This structure is called the hyoid. Think of it like a built-in strap or a seat belt for its own tongue. It starts up near the nostrils, then it loops clean over the skull, then wraps all the way around back, like a tongue with its own ribbon. Picture a party favor unrolling fast. That is basically the woodpecker tongue trick. This crazy tongue helps it eat bugs. It reaches spots the beak cannot. Handy tool, but also a mystery. Some scientists once had a theory. Maybe the wrap cushions the brain too. A nice idea, but not the answer. Remember, the skull is the real hammer. The tongue wrap is just a bonus. A fun extra, not the main fix. Still, that wrap is wildly impressive. No other bird packs quite like this. It is basically nature's built-in gadget. Tiny brain plus stiff skull plus wrap. Together, they make one weird survivor. Every piece works together perfectly. One more surprise is still waiting. Drumming is actually a secret language. It is not always about finding food. Each species has its own drumbeat. Think of it like a birdie ringtone. Some woodpeckers test random surfaces first. They are checking for the loudest echo. A metal pole makes a killer speaker. Neighbors are not always thrilled about it. Real food pecking sounds way quieter. Stealth mode versus show-off mode, basically. Now for the real ecological plot here. Woodpeckers carve almost every tree cavity. 99% in North America alone. Owls and squirrels just move right in. Basically nature's tiniest apartment developer ever. Okay, so let us recap this madness. The invisible helmet idea was totally wrong. The skull is just a stiff hammer. Stiff bones move the shock along fast. The tiny brain barely even notices anything. Everything stops together like one solid block. No wobble means no brain damage happens. That weird tongue also cushions the brain. Nature basically built its own tiny airbag. So it is not magic, just physics. Nature basically built a ridiculous power tool. A stiff hammer with a ridiculous tongue. And it still built half the forest. Not bad for one goofy little bird.